We are
Okay.
starting the class from the first topic, topic 1, physical quantities, units and measurement, right?
Yes.
I think you have idea about all the topics, right?
Yes.
Uh, so far you finished 18 topics, right?
Yes.
And you must have idea about the Cambridge syllabus and contents. Here you see the first topic contents, right? And learning outcomes.
Hmm. Hmm.
Can you see the screen? It's showing in your screen.
Yes, sir.
Okay, what you are seeing?
Sir, I'm seeing section 1, general physics, topic 1, physical quantities, the learning outcomes, context, and scalar and vector.
Okay, good. Okay. Now, now you can see.
No, sir.
Okay. Now,
Yes, sir. Now I can.
okay, fine. So here you see we are going. I don't know how you went with your other teachers or your school, but I follow this. Okay, I follow
Yes.
to uh, go through the learning outcomes given by the Cambridge, so that
Hmm.
if it is not available in your textbook, we can cover. Or sometimes it happens that your textbook has something extra. Those we
Hmm.
do not need according
Hmm.
to Cambridge syllabus, we can skip them.
Yes.
Uh, so here is the first learning outcome. Define the terms scalar and vector. And
Hmm.
here you have in C, list the vectors and scalars from distance, displacement, length, speed,
Hmm.
velocity, time. So we are combining these two learning outcomes in the first discussion, that is scalar and vector. Okay.
Hmm.
You know what is called scalar quantity?
Yes.
What is called scalar quantity?
Uh, Quantities which only have magnitude but no direction.
Okay. What is magnitude?
Uh, mm, Sir, this one I don't know.
Okay. Look, here I gave the definition of scalar quantity. The one you told that it has direction, right? You told about that it has no direction,
Hmm.
no direction, and you told that magnitude, right?
Hmm.
So magnitude means numerical value. You see, I gave here magnitude means I gave here one example. A car is traveling 5 meter per second. So this 5 meter per second is the magnitude. Clear?
Hmm.
This one is giving you one numerical value. So this is
Hmm.
magnitude. Now it's clear. You can say what is magnitude, right? If anyone
Yes.
asks you, you can answer that it is a numerical value. This numerical value might have one unit along with it. Okay, during the
Hmm.
description of any physical quantity. And vector quantity, you know that one has also direction, right?
Yes.
So this one is very clear to you. Here we gave direction, right?
Hmm.
Uh, Car is traveling at a velocity of 5 meter per second towards east. So it's not only giving the magnitude 5 meter per second, it's also gives us the direction, right?
mm,
So that's why it
mm,
is vector quantity. Here I gave some example of uh, scalar quantity.
mm,
Other than speed, we have distance, time, mass, temperature, etc. Okay, and in vector quantity, other than velocity, we have displacement. Here you see we have displacement. Then we have acceleration, force, weight, moment, momentum, etc. You will get some more vector quantities in future. We will
mm,
discuss them step by step. Okay. Now just
mm,
know this all. Okay.
mm.
Now the other learning outcomes. Look, the other learning outcomes determine the resultant of two vectors by a graphical method.
Mm,
Okay, we will try to understand this one. I think you have idea about this, right? When you
mm.
learned this, I think you have idea. So how we do it? Can you give me some idea? This one, determining resultant of two vectors. Any idea, please?
Yes, if
Yeah,
the two forces or vectors are in the same direction, they're added, and if they're in the opposite direction, they are subtracted.
yeah. This is the fundamental one or basic one, right?
Hmm.
If they are working parallel, okay.
Hmm.
If two vectors they are working parallel, then we add them or subtract them, right?
Hmm.
Depending on the direction. If they are working in the same direction, then we are adding them to get the resultant.
Hmm.
Resultant means the sum of the two vectors, right?
Hmm. Yes.
And if they are working in the opposite direction, then we are subtracting, right?
Hmm. Yes.
This way we are doing. Now we are showing you that one what you said, and from there I will try to get some more ideas from you. That here I gave some examples. Here we got 3 and 7, right, in the
Hmm.
same direction.
Hmm.
Then the resultant is coming 10, right?
Yes.
And then the next one 10 minus 3. Why minus 3? Because it's working in the opposite direction, left. So it's
Hmm.
minus 3. Then the
Hmm.
resultant comes 7.
Hmm.
And the last one, you see, two vectors, they are working upwards. Uh, then we are getting 4 plus 4, 8. Now
Hmm.
I'm asking you from this idea, for example, the first one, uh, if we are taking this
Hmm.
one as a vector in opposite direction like this.
Hmm.
Okay, then what will be the value of it?
So it will be -4.
It will be
-4.
minus 4. This one. I'm talking about this one.
Oh, this one will be -7.
Minus
7.
7. Great. So minus 7. Then what will be the resultant?
The resultant will be -4.
Minus
4.
minus 4. Okay, good. this way, right? We are doing this one very simple. And if they are not working parallel, what we'll do then?
Uh, if not parallel, then we can use the parallelogram method
We can,
or graphs. We can use the graphical method or parallelogram method.
okay. So graphical method or parallelogram method. Uh, Graphical method means drawing, right?
Hmm.
That means you have to draw something. You have to draw the parallelogram with the vectors, using the vectors, right?
Hmm.
So let us see them. Here, what you said, the graphical method, that's not only parallelogram rule, we have here two rules. Okay, one
Hmm.
is uh, the first one. You see here, I gave the head and tail method,
Hmm.
and how it works. This one is head, right?
Hmm.
Head of the vector, and this one is the tail. Now we have another vector A. We have to take the tail and head, okay, from these two vectors. Like we can take the head of this one and replace this tail with this head, okay, or we just add, uh, take this vector uh, to join the head of the other vector, okay, or we can take this head joined with the tail of this vector A. Here,
Hmm.
hello, any one we can do. Now what we did here, look, we took the head of A, we just kept A the way it is there, and remove or displaced B to join with the head of A, right? The tail of B. Look here.
Hmm.
So we are getting here A and B in a way that A and B in a way that head of A joins with tail of B, right?
Hmm.
And this is that's why it is called head and tail method. The head to tail method to calculate a resultant which involves lining up the head of the one vector with the tail of the other.
Hmm.
Clear?
Yes.
So these two vectors now on not only giving you the resultant, when we are joining this tail and this head, right?
Hmm.
Then we are getting the resultant. Okay, clear now?
Yes.
And when we are getting the resultant, the way the other two vectors or the given vectors are working in the direction, like A is working in a direction and B is working in a direction, right? And you see they are following the order. If you go start from here, A, then it's going B. That means the arrow is
Hmm.
working in the same direction, right? Or same
Hmm.
order. But when we are getting the resultant, you see resultant's direction is working in opposite. Uh, in another
Hmm.
way around, we can say that A and B, their direction is anti-clockwise. Okay,
The direction.
Samjit? A and
Sir,
B, they are
a part.
hello.
Yes, sir.
Uh, A and B, if you consider they are working in anti-clockwise, then the resultant will work clockwise, right?
Hmm.
So here we got one information, that another information, that is the way the given vectors are working uh, in regarding the direction, right? The resultant
Hmm.
will work in opposite direction. Okay,
Yes.
here now. This is the
Hmm.
uh, fundamental thing, because now in O levels, in most of the questions, they don't ask you about the direction. They only ask you the magnitude of the resultant. But in maths, maybe you will get, or in higher classes, you will mostly get that they will ask you also the direction. So to
Hmm.
get the direction, it's important for you to know the how the vectors are working. That's why we are making this one. You see, if you think of this one is one side of the triangle A, then B is another side of the triangle, and the other side, the third side, completing the triangle, right?
Hmm.
Hello.
Yes, sir.
So this one we can also name as triangle method. Okay,
Hmm.
the head to
Yes.
tail method is also known as triangle method.
Hmm. Yes.
And I made one uh, description of the triangle rule. That one is written here. If two vectors are represented by two sides of a triangle in the same direction, then the third side in opposite direction represent the resultant of those two vectors.
Hmm.
So this one, I think you understand, right?
Yes.
Can you read this triangle method? Can you read this?
Hmm. Yes.
Yeah, read.
I- If two vectors are represented by two sides of a triangle in the same direction, then the third side in the opposite direction represents the resultant of those two vectors.
So, do you have any question here or any doubts here in triangle method?
No.
It's clear, right?
Yes.
Now, what you were talking about, the parallelogram method or parallelogram rule,
Hmm.
that one you also said graphical method, right?
Hmm.
That one we are going now. Here, can you read this?
Uh, if two sides of a parallelogram represent two vectors, then the diagonal through them gives the resultant of those vectors.
So here, F1, F2, these two are given vectors, right?
Hmm.
And we are completing the you see diagram. That is parallelogram.
Hmm.
This parallelogram, it was not there. We have to make it, right, to get the
Hmm.
resultant. Like in question, they will only give you two vectors f1 and f2. Okay, like
Hmm.
f1, maybe they are giving you 5 Newton. Okay,
Hmm.
5 Newton. They are giving you this one as 5 Newton, um,
Hmm.
and this one they will give you 4 Newton. Okay,
Hmm.
so what you have to do in your copy or in your exam paper, what you have to do, you have to draw, right?
Hmm.
uh, 5 Newton, maybe 1 Newton is 1 centimeter, you can consider, right? In ruler,
Hmm.
how you will draw, right? This is the way.
Hmm.
1 Newton is 1 centimeter, so 5 Newton will be how much?
5 centimeter.
5 centimeter. Okay, 5
Hmm.
centimeter. So sorry, 1 Newton is I'm doing undo, no problem. 1 Newton is 1 centimeter. So 5 Newton is 5 centimeter. Then 4 Newton will be 4 centimeter, right?
Hmm.
Now, after drawing these two, uh, you have to do in a way that they are adjacent, right? These two vectors, these two forces, you have to draw in a way that two are adjacent sides of a parallelogram.
Hmm.
Got it?
Hmm.
And after adjacent means they are in contact with each other, right? Isn't it? They will make an angle, right? That's it. That is called adjacent.
Yes.
So
Hmm.
here, after getting these two vectors, what you have to do? You have to complete the parallelogram according to the rule of parallelogram. What is called parallelogram? Can you recall what is called parallelogram?
No.
Yeah. Can you tell me what is called parallelogram?
Sir, I couldn't hear you from the middle. I think so. There was a bit of internet problem.
Okay,
I
now
couldn't.
you are getting me.
Yes.
Okay, so uh, till here you got, right? That they
Hmm.
are adjacent.
Hmm.
So we are talking that we have to complete the parallelogram now,
Hmm.
right? What is the rule or what is called parallelogram? Can you tell me?
Sir, parallelogram is a four-sided shape.
Mm-hmm.
So when two vectors, one is f1, f2, and there is f2. So in order to find the resultant, first we have to complete the parallelogram.
Mm-hmm.
Then we have to
Okay, fine. I'm helping you. What I asked you actually, what is called parallelogram? How you'll complete the parallelogram?
if from
There are some ways, right, to complete. You cannot draw here and there two other lines. There is one rule to draw the parallelogram. That's why you have to know what is called parallelogram.
hmm,
What is called parallelogram? Tell me that one. Can you recall?
which is like a rectangle.
It's like a rectangle, but I need more, specific definition of parallelogram. Uh,
Okay.
yeah.
So, sir, in a parallelogram, the opposite sides are in the same length,
Mm-hmm.
and
That's and parallel. Opposite sides are
parallel.
main thing is the opposite sides are parallel and equal.
Yes.
Okay, that's parallelogram rule or parallelogram definition. Now,
Hmm.
if our this one is 5 centimeter, then the opposite side, this one should be also 5, right? This one
Yes.
should be also 5 centimeter. Sorry, here this one should be also 5 centimeter, right? And this one is 4 Newton, so other side also should be 4 centimeter, right?
Hmm.
This way we will complete the parallelogram, right? And after completing the parallelogram, we have two diagonals of a parallelogram, right? One is
Hmm.
this one, the one we have here drawn, and there is other one. You know that here is another diagonal, right?
Hmm.
This is also diagonal, right?
Hmm.
Hello.
Yes. Yes, sir.
Okay, but which one will take? We will take this one, the one already given, or the one I just drew now. Which one?
Sir, the one which was given from before.
Okay. Why that one?
Sir, because um, it is
It is the
mm,
diagonal
diagonal.
which is
Uh,
going through the vectors given, right?
hmm.
That's why we have to consider this diagonal. This is the most important thing. The students sometimes they are doing wrong. They messed up which diagonal they will take. Okay, so
Yes.
we should be careful that uh, we we should take that diagonal. Diagonal is going through the given vectors. Okay,
Hmm.
clear?
Yes.
So this one I think is the most important thing I have to remind you, or you know we should point this thing carefully, right? That which
Yes.
diagonal we have to take. Now, after getting the diagonal with the ruler, you will measure the length, right?
Yes.
So, if your length is, if you have 5 Newton here and here you have 4 Newton, so what could be the resultant of this? Can you guess?
Yes, sir. You have uh, said we have to find the length of the diagonal.
Hmm.
Then since the length will be in centimeter, you have to convert in by using the unit. 1 centimeter equals to 1 Newton.
1 Newton, yeah. So that's why it is called graphical method. As we are drawing it, and from the drawing we are calculating the values. That's why it is called graphical method.
Method.
Okay,
Yes.
and I
Hmm.
told you that they are sometime asking you about
Hmm.
the direction. What is the direction
Hmm.
of the resultant? That time, what? How can you find the direction?
Sir, direction is the angle
Yeah. How will measure the angle?
by protractor, or yeah, by
Very good.
protractor.
As we are saying it is graphical method, we are getting it by protector, like this angle, right? So
Yes.
the angle between the resultant and vector F2,
Hmm.
or you can find the other angle like the vector F1 and resultant. In between these two, there is another angle, right?
Yes.
Any of the angle you can mention that that will give you the direction. For example, maybe F2 is making here uh, it's maybe 40 degree, right? Maybe or 30. Is it 30? It seems quite 30 or 35, right? Let's see. It is
Hmm.
35. 35 degree. Okay. Let's say it's 35 degrees. So how we will write the direction that
35 degrees. Yeah.
it's how you will write it. You will write that vector F2 or force F2 is making 35 degree with the resultant. Okay,
Yes.
this way.
Hmm.
Uh, the same for this one also. F1. If you are getting here any angle, then you will say uh, the force F1 or the vector F1 is making that angle with the resultant. That's it. It is the way to represent the direction of the resultant. So
Hmm.
that's all about the graphical method. Okay,
Hmm.
clear now?
Yes.
Now, what is our next learning outcome? Can you remember? What
Um,
is
uh,
our next learning outcome?
uh, I think so. About
Yeah,
time.
yeah. Before time, there is another one that is measuring
Oh.
lengths.
Oh yes. Yes.
Measuring lengths. Okay. Before time, there is measuring lengths. Here is the measuring lengths. We are here measuring lengths. Can you read this?
Yes. There are different instruments for measure lengths. Ruler or scale is used to measure a length of till 1 millimeter or 0.1 centimeter accurate. Okay, a meter rule can measure up to 100 centimeter or 1 meter. For measuring lengths more than 1 meter, we have to use measuring tape. Okay.
So this thing you are know, right? You know all these things.
Yes.
Okay, so these are easy for you, right? So in ruler, you have the ruler with you in house. Hello.
Yes, sir.
Now you have any ruler very close to you.
Uh, no, sir.
So you can get one close to you.
Okay, yes.
Yeah. So your ruler is 15 centimeter or 30 centimeter. Samjit?
Yes, sir. I'm back.
Yeah. So your ruler is 15 centimeter or 30 centimeter.
30 centimeter.
30 centimeter, and each of the centimeter is divided into 10 equal parts, right? Hello? Hello, Tamjid? Hello? Hello?
Hello.
Yes, Tamjid? Hello?
Yes, sir.
Tamjid? Yeah. Each of the centimeter is divided into 10 equal parts, right?
Yeah, right. Hello. Ki koi gelo?
Yes, yes.
Wait,
Are
wait.
you there?
Oh,
Tamjid?
yes, sir.
So each of the
Yes, sir.
centimeter is divided into 10 equal parts, right?
Yes.
So each part is giving you 1 millimeter,
Hmm.
isn't it?
Hmm.
1 millimeter or zero point 0.1 centimeter. we can say, right?
Yes.
That's why here we wrote this 1 millimeter or 0.1 centimeter accurately. So a ruler and scale is giving you accuracy till 1 millimeter. Uh, if the length is smaller than that, like you have to measure less than 1 millimeter accurately, then which instrument you will use?
Less than 1 millimeter will be micrometer.
Uh, there is another one, vernier calipers, right?
Oh yes, yes.
Vernier calipers, you can measure with vernier caliper 0.1 millimeter accurately.
Yes.
Okay, that means if you divide 1 millimeter in 10 equal parts, you think of or imagine that length is very small, right?
Yes.
That small length even you can measure accurately with vernier calipers. Okay, and
Yes.
even smaller,
Hmm.
even smaller than 0.1 millimeter, you can measure accurately with micrometer, the one you were saying.
Hmm.
Okay, so
Hmm.
that one is like that. If you are dividing 1 millimeter into 100 equal parts,
Hmm.
can you imagine your ruler is in front of you? If you
Hmm.
divide 1 millimeter space into 100 equal parts, then that one part of 100 you can measure
Hmm.
accurately using which instrument?
Micrometer.
Micrometer. So that one is giving us 0.01 millimeter accurately.
Hmm.
Here we are
Yes.
going to discuss those how we are getting the reading in the vernier calipers and
Hmm.
how to calculate from the reading. You check this one here, vernier calipers, right?
Hmm.
Look, you can see vernier
Hmm.
calipers.
Yes.
Okay, so can you read the diagram?
Um, so read the diagram.
Yeah, yeah, diagram. Different things are labeled there. You can see, right? Here
Yes.
I'm making it bigger. You can see clearly. Yeah. Now, please read.
Yes. Jaws for measuring inner dimensions.
Like,
Jaws.
yes, wait. Jaws for measuring inner dimensions. Do you understand this?
Yes.
So, what does it mean, inner dimensions?
Like to find the length, uh, like to find like the diameter of the inside of a cup, or
Yeah, inside of a cup or in inner part of the cup, right?
hmm,
That one is called inner dimensions. Like we are going to find the internal diameter. Okay, that is called inner dimensions. That time we are using the upper jaws, right?
yes.
And the lower one, read this.
Uh, Lower one is jaws for measuring outer dimensions.
Yeah, here now this one. So there are four jaws here. The upper jaws are used for measuring internal diameters, and the lower jaws, those are used for measuring what?
The outer
External,
dimensions,
external
external.
diameters, right? like you are giving one measuring cylinder. In one measuring cylinder, there is internal diameter and also external diameter, right?
Hmm.
So according to your need, you can measure any one of them. Clear
Hmm.
to you now?
Yes.
Okay, then next.
Um, Next one is skew clamp
Mm-hmm.
and the vernier calipers.
Yeah, vernier scale, right? Vernier scale. This one is
Vernier
called
scale,
vernier
vernier
scale.
scale.
Look, this one is main scale. Hmm. This main
Hmm.
scale is given in centimeter. Okay, and the vernier scale, we have to take only the numbers, not
Hmm.
any centimeter here, right? Only we
Hmm.
have to take the numbers. Which number is matching with the upper? There are lots of lines above it, right?
Hmm.
And also on vernier scale, there are lines, right?
Hmm.
So we have to check out the upper line and lower line where it meets, right?
Hmm.
That one will be our vernier scale reading. Okay.
Hmm. Yes.
So after getting the main scale reading, you see here 3 point where it is 0, we have to take there. The vernier scale is 0 here, right?
Hmm.
So till 0, what will be the main scale reading? That one will take. Okay,
Hmm.
for example, here we got uh, how much? 3.1, right?
Yes. Different one.
Yeah, yeah. Then after that, there are a little bit values, but we don't know how much it is exactly. That one we'll have to take from vernier scale. Okay.
Hmm.
Now we are going to find it from one example. Look, this one. This one is more clear, right now?
Hmm. Yes.
Okay, how to get the reading from scale, vernier scale, main scale, and how to get the uh, you know total reading accurately. We are going to find that one. So look here, this one is main scale, right?
Hmm.
What is the reading in the main scale?
It's 2.1.
Very good. So here we wrote here 2.1 centimeter, right?
Hmm.
Then
Then the vernier scale reading is 3.
3.
Yes.
3 is multiplied with 0.01 centimeter, right?
Yes.
So what we discussed before about the accuracy of vernier calipers, that is uh, in ruler, the ruler you have with you, that one is measuring 1 millimeter accurately, right?
Yes.
And vernier calipers, we say that it can measure 0.1 millimeter, right?
Hmm.
Right?
Yes.
And 0.1 millimeter means in centimeter it is 0.01 centimeter,
Yes.
isn't it?
Yes.
That's why we have to multiply with this 3, the one we got from vernier scale. That one is 3 will be multiplied with 0.01 and the unit will be centimeter, right? If
Yes.
you get the answer, it will come 0.03 centimeter. So your main scale reading is MSR, it's giving you 2.1, and your VSR, that is vernier scale reading, this is giving you 0.03, right?
Yes.
So what will be the total length?
It will be the main scale reading plus the vernier scale reading. So 2.1 plus 0.03, 2.1.
So if you get similar questions in Cambridge, then you can solve, right?
Hmm.
So tell me, before my class, you got this idea or it is new for you today?
No, sir, I have this idea.
You have this idea before. Okay, very good. So it's giving you another revision, right? To get how to calculate uh, or how to get the reading in vernier calipers. Okay. Hello, Tamjid. Hello, Tamjid. Hello, Tamjid. Hello, Tamjid.